Hello everyone, welcome back to Siri YouTube channel. In this video, we will study about 9th standard chemistry, atoms and molecules. Briefly, okay. If we take introduction, we'll get two names mainly, Maharshi Kanad and Anthony Lavoisier. Okay. Maharshi Kanad is an Indian philosopher postulated that if we go on dividing the matter, that is called as Padarth, he called that as what? Padarth. If we go on dividing the matter, then we will get smaller and the smallest particles. Okay. He called these smallest particles as what? Paramanu. Who called that as Paramanu? Maharshi Kanad. Who called that word Paramanu? Maharshi Kanad called that smaller and smallest particles of each matter, that is nothing but Padarth, as Paramanu. Behind in the same era, Greek philosopher Democritus called this indivisible. We can't divide that particle, that smallest particle, okay na? That indivisible particle as an atom. Atom is nothing but indivisible particle of a matter. Who called that as atom? Atom is called by Greek philosopher Democritus. Yes. By the end of 18th century, scientists recognized the difference between elements and the compounds. Already we have studied the meaning of element and the compound in the previous chapter. Yes? Yes. Elements are the substances having molecules of the same type of atoms. Elements composed of identical atoms. I'll take H2 molecule. H2 molecule. I'll take this H2 as element. Why? Because this element contains two hydrogen atoms only. Same kind of atoms, that is identical. Identical is nothing but same. Okay. A compound is composed of two or more elements chemically combined. We can't divide it by physically. Chemically combined with each other in a definite proportion by weight. I'll consider for that H2O. H2O is an example of compound. Why? Because this compound contains hydrogen and oxygen. Two or more elements are involved here, correct? Hydrogen and oxygen. It is chemically combined in the ratio 2:1. Look here, chemical formula of the water is H2O. 2 atom of hydrogen and 1 atom of what? Oxygen. So we consider this as what? Compound. Understood? Yes. Then one more very important scientist, we have talked about him already, correct? Anthony Lavoisier. Anthony, I'll write here. Anthony Lavoisier. Correct? Is a very important scientist who have given two important laws. Okay. First one is law of conservation of mass. Let's state that way. That law of conservation of mass. law states that mass can neither be created nor be destroyed during a chemical reaction. Okay? Yeah. Mention it. Mass can neither be created nor be destroyed in a chemical reaction, which means sum of the masses of the reactant is equal to sum of masses of all the product. We can write this as sum of mass of reactants which are going to react is equal to sum of masses of products. Yes, for this we'll take one example. CH4 methane is reacting with 2 molecule of oxygen, which yields a molecule of carbon dioxide and 2 molecules of water. You check. See, here we have one atom, here we have one. This is the reactant side. This represents the chemical which are reacting to yield some product. Okay. One carbon balanced in both the sides. Hydrogen 4 we have here, 2 hydrogen with 2 into 2 4 hydrogen. This also balanced. Done. Next we left out with oxygen. Here we have 2 oxygen, here we have 1 into 2 is 2, 4 totally we have in the product side. Then here we have 2 into 2, 4 oxygen. Yes, this here mass of the reactants is equal to mass of the product. Now 1 carbon, 4 hydrogen, here also 4 hydrogen, 4 oxygen, here also 4 oxygen. Okay, yes. Yes, next we have law of constant proportion. Law of constant proportion. We can say this as law of definite proportion also. This is established. This was established by Joseph L. Frost. What is that? Joseph L. Frost. This law states that in a chemical substance of the elements are always present in definite proportion by mass. In a chemical substance, mention that it states that in a chemical substance, yes, substance, the elements are always present. The elements are always present in what? In definite proportion. In definite proportion by mass. Here mass refers to the atomic mass of the each elements. For this we will take example of 2H2O and CO2. This holds good for law of constant proportion. Next we have law of multiple proportion. Law of multiple proportion. This law can be stated as different weight of an element combined with a fixed weight of the other element by a simple numerical ratio. Yes, let's state that. Okay, different weight of what? Of an element different weight of an element that combine in a fixed weight by its simple numerical ratio. For this, let us take a ratio. For this, let's take one example. NO, NO2, N2O, N2O2, N2O5. We know that atomic mass number of nitrogen is what? 14. Oxygen will be what? S. 16. Right here. Atomic mass number of nitrogen will be 14, 16. Here 14. Here 16 into 2. That is nothing but 16 2s are 32. Here 14 into 2, 28. Then will be oxygen's 16. Then 14 into 2, 28. 16 into 2, 32. Then here 16 into 2, 32. Then 14 into 2, 28. Oxygens will be 16 into 5. That will be 80. Correct? If we take this compound, then it is in the ratio 1:1. 1 nitrogen, 1 oxygen, 1 nitrogen, 2 oxygen, 2 nitrogen, 1 oxygen, 2 nitrogen, 2 oxygen. It's of 1:1 ratio. Then 2 nitrogen, 5 oxygen. It's in the simple numerical ratios, right? 1:1. It's not the complicated, not 15:16 like that. Yes, it's the law of conservation of mass, law of constant proportion, and law of the multiple proportion. Okay, let's end of this session. In the next video, we'll study more about this chapter. Thank you so much.